Hello, Honors Geometry students. Welcome to your first video of 2021. We are going to be doing our final transformations today, which is dilations. All right, so remember, we've already done rotations, reflections, and translations. This is going to be our last one here. Okay. All right, so first up, what is a dilation? A dilation is a transformation where a figure changes shape, but not size. So we expand or shrink proportionally about a center. Angles stay congruent. Remember, this is our only transformation where the image and the pre-image are not congruent to each other. All right. So our vocab word, we've got scale factor. Is going to be the ratio of side lengths of the image, the corresponding side lengths of the pre-image. So again, this is just kind of how they're related to each other. We talk about scale factor with lots of other things. So we use that letter K to represent scale factor. All right. Now, whenever I'm determining scale factor, we always do the distance from the image to the pre-image. All right. So when I'm looking at, my how I'm going to calculate my scale factor, we always do prime distance over pre-image distance. And I'll show you what that means in a minute here. Okay. But the prime distance is going to be your image, right? So it's always image. So another way to think about this one right here would be we always go image over pre-image. Okay. All right, so one of two things is going to happen. First and foremost, K, my scale factor, will never be 0, okay? Or never be less than 0. You'll never have a scale factor that is negative. You'll never have a scale factor that is 0, okay? So two things are going to happen. First thing, you're going to have a scale factor between 0 and 1. So some sort of fraction, 1/2, 1/5. 2/3, something like that. Some sort of fraction between 0 and 1. Now, it won't equal 0, like I already mentioned, and it won't equal 1. If we have a scale factor of 1, that means it hasn't changed at all. It's going to be exactly the same. Okay, so less than 1, but greater than 0. So if we have a scale factor that's between 0 and 1, this is going to be an example of a reduction, okay, meaning that my image is going to be smaller than my pre-image. Okay. The other thing that's going to happen is my scale factor will be bigger than 1. Now, how much bigger than 1? We don't have a limit on this one. Okay. It can be anywhere from 1.1, to 1,000. Okay. So as long as it's bigger than 1, this is going to be an enlargement. Okay. So the pre-image will get bigger as I move to the image. Okay. So based on what the scale factor is, that'll kind of tell you what's going to happen to my shape. All right, so we're going to do a couple examples, just identifying these dilations. So first and foremost, we want to determine whether it's a reduction or an enlargement, and then we're going to go ahead and figure out what the scale factor is. Okay, so we always want to kind of look at these shapes, as two parts. So I've got my my pre-image, remember, which is going to have all of my regular letters, so A, B, C, and D. That's going to be my pre-image. My image is going to have my prime notation, so A prime, B prime, C prime, and D prime. And so just kind of looking at these two, before we even look at the scale factor, we can tell, did the red rectangle, as I move from red to blue, as I went from pre-image to image, did I get bigger or did I get smaller? Well, obviously in this case, we got smaller. Okay, so this is going to be an example of a reduction. Okay, because that red rectangle got smaller as I moved to the blue one. All right, so the next thing I want to do here is I want to determine the scale factor. All right, the scale factor of this dilation. So what we want to do is pick two corresponding sides, and I'm just going to pick these sides on the left here. We're going to do. So I'll just do, AD right there, and A prime D prime. So we'll just pick those two sides right there. Again, pick a pair of corresponding sides. You can pick whichever ones you want to. I'm just going to pick these two to start off with. Okay. All right. So AD. If I look at this. The length of AD, if I count from A to D, is going to be 4 units from A to D. For A prime, D prime, again, count from there to there, and I'm going to get 2. Now, as I mentioned before, whenever I do a scale factor, I always want to do image over pre-image. And that's what I mean for this one, okay? My image right here is going to be 2. That's my image distance. My pre-image distance right here is going to be 4. So when I go to write this out, I'm going to do my image distance, which is A prime, D prime, over my pre-image distance, which is going to be AD. So 2 over 4, which is going to reduce to 1/2. So we have a scale factor of 1/2. Now, again, going back to what we just talked about a little bit ago, as far as where K falls, 1/2, it falls between 0 and 1. So again, this is an example of a reduction. So that just kind of confirms what I had up top. Okay, so you have a reduction where my scale factor is 1/2. All right. All right, so moving on to the next one. Again, same exact idea. Okay, I want you guys to try this one on your own real quick, and then we'll do it together. So go ahead and pause the video, and then we'll kind of go through this one together. All right, pre-image is the smaller square in the middle here, okay? E, F, G, H. That's my pre-image. Again, I know that because there's no prime notation there, okay? My image is going to be the big square, again, because it has all that prime notation on there. So again, like the previous one, it doesn't matter which pair of sides you pick. Just pick one pair of corresponding sides, all right? So again, for my pre-image, I'm just going to we'll pick HG, okay? And HG is 3 units. From H to G is 3, all right? And then my corresponding one is going to be H prime, G prime. And again, if I count from H prime to G prime, I get 9 for this one. So remember, when I go scale factor, I want to go image over pre-image. So my image in this case is going to be 9. Okay, that's the image. Over pre-image, which is going to be 3. The part that I should have let off here with, sorry, is whether or not this is a reduction or an enlargement. And again, red is my pre-image, and then blue is my image. So red's what I start with, blue's what I finish with. And obviously, as I go from red to blue, I get bigger. So this is going to be an enlargement. So this is kind of another way you can kind of check yourself. We know that my enlargement, because it's going to be a number bigger than 1, my scale factor should be a number that's bigger than 1. So coming back to here, again, I did my image distance, which was HG, over my pre-image distance, which was 3. 9 over 3 is going to reduce to 3 over 1, or just 3. You can write it as 3. You can write it as 3 divided by 1. It really doesn't matter. All right, so we have an enlargement and a scale factor of 3. All right, so that's just looking at two shapes that have already been dilated, determining if it's a reduction or enlargement, and then finding out the scale factor from there. All right, in example number 2, we are given 3 points, and we want to dilate these points about the origin. Okay, so take a second, go ahead and write down this triangle, kind of graph it on your graph paper. Write down A is -3, 0, B is 0, 6, and C is 3, 6. Now we are going to dilate this by a scale factor of 1/3. Okay, so what we're going to do is something called scalar multiplication, and we'll walk you through this. Let's start off by writing all my points. So we'll start off by writing out my pre-image, which is ABC. A is the point -3, 0. Okay, B is the point 0, 6, and C is the point 3, 6. Okay, so this is going to look similar to what we did when we did our translations. I'm going to take these points and I'm going to change every single one of them, okay, using my scale factor that was given to me of 1/3. So K equals 1/3. And as we know, I'm going to get 3 new points. I'm going to get A prime, I'm going to get B prime, and I'm going to get C prime. All right, here's how scalar multiplication works. We're going to take my scale factor, which is 1/3, and I'm going to multiply that by my x and my y coordinate in every single one of these points. And that's going to give me my image point. So 1/3 times -3 is -1, so this is going to be my x coordinate for A prime. All right, 0 times 1/3 is going to be 0, so that's my y coordinate for A prime. Keep going. All right, 1/3 times 0 is going to be 0, so that's going to be my x coordinate for B prime. 1/3 times 6 is going to be 2, so 2 will be my y coordinate in B prime. And then for C, I'm going 1/3 times 3, which will give me 1. And then lastly, I've got 1/3 times 6, which gives me 2. So these are the coordinates for my image. Now remember that scale factor is 1/3, which is between 0 and 1, so this should be getting smaller. Let's go ahead and graph my image points, A prime, B prime, and C prime. So A prime is the point -1, 0. That's going to be right there. B prime is the point 0, 2, which will be right there. And then C prime will be the point 1, 2, which is going to be right there. And as you can see, as I graph this, we've taken that triangle, we've made it smaller. Now remember, guys, when it comes to dilations, the two shapes should look exactly the same. Just in this case, the blue one is smaller than the red one. Okay, a triangle looks exactly the same. It's just a smaller version of it. All right, and again, we use scalar multiplication about this one. Now, So this is an important thing to point out here, guys, is we use scalar multiplication only when we have the dilation center is at the origin, okay? That is 0, 0. It's the only time I can use scalar multiplication. We will dilate about points that aren't the origin, but we'll kind of talk about that more in depth tomorrow in class, okay? So again, if we have a dilation center to the origin, we just use scalar multiplication. All right, then finally, example number 3 here today. I talked about dilating points about a point that aren't the origin. Again, we're going to talk about this more in depth in class, but right now, what we have is two triangles. We have a pre-image and an image, and what we want to do is figure out what the center of dilation is going to be. All right, so again, I'm just going to kind of outline these. So we have them. So there is my pre-image, and again, I know that because none of the points are prime. And I've got my image, which is going to be R prime, T prime, and S prime. All right, and I'm trying to figure out what is the center of dilation for this one. Now, I said I'll give you a hint, it's not the origin. And the way that I'm actually going to do this is something kind of cool happens with this as I kind of do all my points, as I make my image points here. And again, I can kind of show you up here with some of these ones, is if I connect, two image points, so like let's say I connect A to A prime. All right, so I get this line right here, right? But then what's going to happen too is I do B and B prime. Okay, and then lastly, if I go C and C prime and I connect those 2 points together, what do we notice that happens here? Okay, well, we notice that all of these points are going to congregate right here at 0, 0, which is that center of dilation. Okay, so if I want to find the center of dilation, all I need to do is connect my image points. Okay, so again, I'll show you what that means. So here are my points. I have R and R prime. I'm going to draw a line from R prime to R. Again, kind of straight line, and I'm going to extend it past here to give myself this straight line. And again, this is going to look something like this. Okay, so that is my line joining R prime and R. And then just do it for the other two as well. So T prime to T, extend a line through here. Okay, and then lastly, go S to S prime. Connect those together. And again, I am looking for what is the point where all three of these lines come together. And it's going to be right there at that point, which is going to be the point 1, 3. So again, this point right there is the point 1, 3. Okay, and that's going to be my center of dilation. So if I kind of get rid of some of these, and then one way to kind of verify this is kind of double check those distances from 1, 3 to, all these other parts. And again, what I mean by that is how do I get from R to there? So this is going to be up 2 and over 1. If I go from R to R prime, I'm going to go up 2, 3, 4 over 1, 2. All right. And then I do the same thing for S. Over 1, 2, 3, 4, down 1, 2. So that's 4 and that's 2. If I go to S prime, I go 1, 2, 3, 4, 5, 6, 7, 8. Down 1, 2, 3, 4. So you'll see that whole distance is 8 and that whole distance is 4. We've actually doubled that distance just like we did up here. Okay. So again, if I want to find that center of dilation, connect those 2 points together and that'll give it to you. Okay. So for this one, my center of dilation is going to be the point 1, 3. And again, we will explore centers of dilation that aren't the origin a little bit more in depth together in class. All right, go ahead and try these. You try nows. Don't worry about number 1. You can skip that one. Definitely do number 2. And then number 3 is exactly that problem that I was just talking about. Okay, we've got a center of dilation that is not the origin. Okay, so you can't do regular scalar multiplication here, but I want you guys to try this one on your own anyway. Okay, give it a shot. Try it on your own and see if you can figure out how exactly we do dilations where we don't have a center of dilation that's not the origin. All right, so go ahead and give these two a shot. And again, like I said, we will talk about them more in depth tomorrow. Have a good day.